Well, we're really grateful for Nicola for coming to us today. I've known you for about since you moved here.
Since we moved here, yeah, before Sid.
Really awesome. Her husband is a renowned fine artist. He's a sculptor, and he also cuts my hair sometimes.
and is stuck with me. So there's lots of stories around that. My dear husband didn't believe that there was stone in New Zealand, which isn't of Irish quality, so he decided to pack a container with 11.5 ton of stone, a 3.5 ton forklift, and I fitted in the dining room table. So it was a bit of a mammoth move over here. But thank you to Sid, and thank you to every single one of you guys. I remember where you're sitting now. I didn't get those nice words when we were leaving. But I guess what I'm trying to do today is give you guys an insight into what we do as a company, Central Heating New Zealand. But as Sid and myself were talking, Sid asked me to go into a little bit about how I got to where I am today, right? I have a running joke when people say, how do you end up as operations manager of Central Heating New Zealand? I typically say confused.com, and you probably get a feel for it as I go through it, all right? I forgot my clicky, so I'll have to click off this, so hopefully you guys can follow it, and plus follow the accent. So I'll go through a bit about the background, where I'm from. I actually qualified in structural engineering. Like you guys, it's a pretty difficult degree. I did mine in Cork, in Ireland, and there was 126 of us started it. It was a specialised degree at the time, and only 9 of us finished it. So it was pretty robust. They actually had an accolade on us at the time because my university was trying to put it as the prime structural engineering degree within the EU, which is like a huge thing. So I'd never done German, and I had to learn German. That was number one. But B, they never told us the cut-off point, so I was constantly fight tooth and nail to actually get to the next year. All right. I went through a couple of changes, which I'll go through. Moved to New Zealand, and now I'm with Central Heating New Zealand. So I'll go into a bit of detail on that. Irish roots, gotta get this out of the way. Don't know if anybody was ever in Ireland, but Ireland has the same population as New Zealand. All right, we've got about 5 million people, or when I was there. But it's a quarter of the size, so it's pretty darn small. Where I'm from is literally down in the south, the best county called Cork, and it's the largest county in Ireland. Where it all began, literally I'm from a wee beach resort, if you can call Ireland a beach resort with 350 days of rain. But I'm from that wee little resort. Firebird, which we call Balia Vikira, actually has a donation later on as I get through to it. It'll just give you a bit of perspective as to Ireland. A little bit about where I was brought up. We've got, anybody into cooking? Okay, so we've got Ballinaloo Cookery School, literally a kilometre down the road from me. So that's Rachel Allen, Dreen Allen, you might have seen those guys on TV. The other thing, which you probably all know, is Jameson Irish Whiskey is literally made in the town where I'm from. So I do not like it because I was brought up with the smell of the maize, literally being distilled all the time. So I can't stand it, but I knew you'd appreciate that one. This is the wee little township I'm from, and we look out on 2 islands. One small interesting fact is the island with the lighthouse. That was the last manned lighthouse in Ireland. And I still remember, I was probably 8, 9, I remember that man coming off the boat onto the pier. And all the media and everybody was there, and it became automated there afterwards. So it's a very famous village. Not really. For myself, I am one of 3 siblings, one of 3 kids, and my dad always wanted a boy. He had 3 girls. So at the tender age of 7 years of age, I was always trying to hang out with my dad. I actually started plumbing. So by 13 years of age, I could plumb a house, rip a boiler to pieces, put it all together. I worked with my dad every single Saturday, all through school, right through university. It involved everything. So it was septic tanks, sewers, the whole thing. Look at the size of me, I'm not very big. So if it was nowadays, he'd probably be brought up for something with the corners and all the little bits that he shoved me into. But that's really where I started. In Ireland, you get to high school, you're into high school at 18 years of age. So it's a pretty long process. So I got to that age and my dad said to me, what are you going to do? And I said, I'm doing it. I'm going to do an apprenticeship. And he said, no, girl. You're going to go away and you're going to get something in your back pocket. So all of a sudden I had a challenge. Flip, what do I actually want to do? All I've known is plumbing. Default would have been mechanical engineering. But there was a couple of bits that stood out. The bridge that you guys see there was being built about 6-7 miles down the road from me. And I used to pass it an awful lot in the van with my dad and on the school bus. And I was always intrigued about it. So I started exploring structural engineering. And as I said, I followed through, did 5 years in university, and was 1 of 9 that came out at the end of it. So I hit the big bad world, exactly where you guys are going now. And I just said I'd give you a bit of a snapshot as to a couple of the projects I did. Bana Beach was a big leisure centre, not the capacity of Metro Sports, but a big leisure centre. Blackwater Motors literally built a whole new, it'd be like a light industrial estate, started a light industrial estate. The interesting thing about structures and foundations in Ireland is that you get limestone, where the limestone actually has major fissures inside it. So you think you're on good ground, and all of a sudden the minute you start digging, it just starts disappearing. So it doesn't shake, it just disappears. So that was one of those sites where, as we started opening up the ground, it literally started washing away through swallow holes. So you're trying to change your whole construction of it. The last one it's called Harty's Quay, and it was a multi-millionaire in Cork who said, that's wasteland, I want to make millions out of it. And literally we had to pile the whole land, and we built equivalent to 2,500 people living on it. So started out with a couple of interesting ones, and then I got the teeth and bones. So got out of my junior phase and started getting my own projects. My first major project was a wastewater treatment facility for about 150,000 people, so it was a reasonable sized township. Again, the big thing about this was it's interesting designing the concrete that has to hold the poo and be treated and so on. But the massive thing was the minute the rain came, this whole site flooded. So we weren't interested in holding the poo, we were interested in actually weighing the whole thing down, making sure it stayed in the ground, because very easily the whole thing would have lifted up. So nice, interesting projects. Cork City, similar to any city, started out with its landfills in a not very economical, logical pattern of disposing their waste. So this site originally opened up in the 1960s. And you can imagine, I was able to go down with my trailer and throw in my waste. The tyre shop could go down and throw their tyres in on top of my waste. It was literally all for one in across about 1.5 acres. As legislation developed, the rest of the site was actually filled accordingly. But we were asked, I was with, they're actually a global engineering company, they're called RPS Consulting. They're not based in New Zealand, they're huge in Australia. They've got about 5,000 engineers. So I was with them at this point, and we to do a feasibility study on building on that bad section of land. Where'd you start? So we teed in with a company in LA that had undertaken kind of a similar thing. But the whole issue for us is we went in, and you know the pile drivers that literally drive the pods, we said we'd start by driving some pods. So we drive one and we get down 300 mil, and we'd hit rubber, and the whole thing would just start bouncing. And we'd hit another, and it felt as if we were hitting the thickest concrete wall you could find. So we spent weeks on this site just trying to figure out what was inside it. As we were dropping the piles, we were getting methane flying out of it. Like, it was terrible how they dumped way back in those days. But as we worked through it, we discovered that they could build a portion of buildings on it. But what we didn't know was the settlement. So when we put a load on one section of it, but if a car parked next to it, you have to get the people into the building. So what we were going to do was literally float the footpaths and float the buildings. So we'd allow everything to move. So in other words, if the buildings sank 0.5 metre, we could actually get the footpaths to actually move with it. Wow. Very, very interesting project. I did my confused.com, but they did actually end up building on a section of the site. So very, very interesting. Another one which just gives you a bit of a design as to how I started to specialise. This was a flood region. I make it sound as if the whole of Ireland floods, but it kind of does. Another one in Cork City where we were demolishing an existing building, but in a flood region they wanted a double basement car park. So it was new at the time, it ain't too new anymore. But sequence pile walling, right? That's where they literally build the piles so you can build a basement. But what they actually do is they drive one good pile, leave a gap between it, drive another good pile, and set them out all the way. And then when you look at this photograph, you can see it's like as if there's half piles stuck in there. They just infill the sections. But it's one of the quickest way to waterproof a basement ever. So I looked at the sequence piles for that design. But out of that project, what I started to specialise in was finite element analysis. I didn't break it, did I?
You didn't do anything wrong.
Finite element analysis. So what that was is, when I came out of uni, everybody was like, you design on paper, so everything was kind of manual, and there was a bit of Excel, but everybody was still scared of it. So I started modelling a building in 3D. I basically draw the whole building in AutoCAD and then do 3D wind loading on it, and things just became narrower. So instead of big block beams, everything becomes more streamlined. So because of those skills I developed, I started to go down different routes. As a result of that, I actually got contracted out to Eli Lilly. Ireland's full of pharmaceuticals, Apple, the whole lot of them are there because of corporation tax, cheap corporation tax. Eli Lilly is based in Cork, one of the pharmas. At the time when I was there, you can see 700 people were employed, but there was 700 contractors also on site. To walk from one end of the site to the other, it was a mile. That was pretty big. So I went in, and my first task was to look at all the existing tanks and structures and to tell them what life they'd left. So we literally had to do resistance readings in against the steel tanks and the concrete tanks, measure the amount of erosion that was after taking place, and then I had to predict the lifespan of that tank. So I spent about 6 months doing that, and then they said, okay, you can actually stay on board, we want you as the structural engineer for the site. So it was pretty exciting and interesting projects. I could talk all day about it, but a couple of bits was I launched the EU and Asian call centre for them, and the whole bio thing was taking off at the time. So I mean, the COVID drug or vaccine that we're all getting now is a bio drug. But when I was looking at this at the time, bio was unknown still. And they built one facility for $350 million when I was there, and the drug failed just before they launched it. You know, it like pharma's just another world. And I do have a comment, my plumbing always came in. If there was a blocked toilet, I was the one that they still called to cure. I guess there's a couple of points I'm trying to bring up as I go through this. The finite element analysis, the other bits and pieces. You guys will find as you get out there, as you progress through your working career, you'll get these little snippets of how you're actually developing your skills, and take all of them, take every single opportunity. Like that Eli Lilly section for me exposed me to project management. So all of a sudden I had to look at scheduling, all the trades involved, health and safety, ISO legislation. Like it opened up a whole new realm to me. So if I didn't push my boundaries with finite element analysis, I never would have ended up in Eli Lilly, I never would have ended up with those skills. You know what I mean? The other big thing is continuous improvement, continuous development. Keep pushing yourselves when you're out there. I, sadly enough, and had a patient husband, decided to do a sustainable degree. I was about 8 years out of university, people were talking green, and I went, screw this. This is where the industry's going to go. I actually need to upskill again. So I did another degree at night. Nearly killed me, but I did it. I came out at the time at the end of it and went, that was kind of a waste, nothing's actually green, but things are changing slowly now. Other little bits, because I was in Eli Lilly, I said, right, I'll do clean room facility training, which is huge. To design a clean room for a lab is absolutely mind-blowing. I mean, think of it, you can't have one ledge that will actually generate a germ or dust on it, you know, so it was really intriguing. Another thing, and Sid and myself spoke briefly about this, is in Ireland they have the Irish Institute of Engineers, so that's mechanical, HVAC, electrical, structural, civil. and it's like a membership that you pay towards, and you do your CPD out of it. I established the Young Engineers Society out of it, and out of that, it was really more lectures that we as young engineers were interested in, rather than the 60-year-old engineer who'd been around forever and wasn't interested in what we were in, right? So we easily obtained industry to come into us. But the other thing it opened up to is we were able to turn around to the equivalent of Metro Sports, right? To CPB that are building that and say, can we actually have a site tour? Because the more experience of physically seeing things for you guys when you get out there now, the quicker everything locks into place. You know, you have the theory, now it's to put the picture and all the blocks together, and you absolutely soar. So Sid and myself have spoken about it, and it's something I think should be set up for all you guys when you're out there. You should have your own society that you can actually reach out and get industry in to keep developing your skills. Then the real confusion starts. So when I was in Eli Lilly, I was approached by a company called Firebird. They knew my plumbing background, my engineering, blah, 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 and said, would you be keen to come on board? We're looking for somebody, we're getting into renewables, would you be interested in actually joining us? So I made the jump and I joined Firebird. Firebird started way back in 1980, but just to explain, and I'm kind of jumping the gun, but just to explain what Firebird are, is they're a boiler manufacturing company. Difference is, and this will show you the path to central heating New Zealand, difference is in Ireland is, and the UK and Europe, central heating, whole home heating is part of the building code. You cannot build a house without heating the bedrooms. You know, a high wall on the wall ain't good enough over there. Right, and you guys, I can see, appreciate that straight away. So like, when I was plumbing with that, automatically it was your sewers, your downpipes, hot and cold water, your central heating. Firebird started in 1980, and they were the first to really have a convenient form of central heating. So what it was an open fireplace, and it was a steel box that you see up at the top that sat into it. That had a couple of pipes came off it, flow and return pipes came off it, you light your fire, the hot water circulates around to the radiators in each of the room, right? Very basic, very simple, but it went through the roof. So it was two guys founded it in their garage. Very, very quickly, sorry, that just gives you a layout, which I've explained. I'll come back to that one. Very quickly they expanded, and in 1986 they actually designed what's called the Popular, because it's so popular, the Popular boiler. That boiler from 1986, only a couple of minor tweaks in it, is still on the market today. But to go back, you mentioned, when I showed you the map of Cork, I had Garryvoe and I had Ballyvakira. The interesting thing about where the factory is located is, it's in a Gaeltacht. So a Gaeltacht is an Irish-speaking village. We still have them. For us growing up in school, we have to learn our national language all the way until we finish high school. The only place you don't have to do it is in university. So we all grew up hating it, absolutely despised it. But I was out in the working world speaking English every day. I joined this company and I walked down the factory. Morning, how are you? How's everything? None of them spoke to me. Why? I didn't speak to them in Irish. Got us to talk to? Straight away I got away. So I had to go back and learn all my Irish. But it's from a very, very famous village, and they have their own dancing, they've everything. It's like a rainbow to be inside there. But the whole factory speaks Oscuelga every single day. And the company made some dramatic changes. They were one of the first Irish-founded factories that actually became robotic. So across 3 years, they went from 50 plus welders inside in their factory, welding all the boilers, to absolutely robotic. I have a couple of photos coming up to show you guys. What do? They've got over 80 models that go from a small 12 kilowatt boiler right up to 100 kilowatts. They've expanded into different regions, but that's primarily the boiler section of it. The factory produces about 80,000 boilers a year. So she's not a small bird. Everything inside comes in as a raw sheet of metal. So when we're talking the casings, everything, the main boiler steel, it comes in literally as you see from the photograph there. First process it goes through is actually the main cutting. So everything's drawn out in AutoCAD. and it literally goes through the laser cutting machines, and they'll cut out all the little holes and shapes for the boiler. Next section is the folding, so they're on the trump machines, and they literally can pick up the piece of metal and do a full 360 rotation and keep bending it until it's got its actual turned, cornered shape. Manually it is fed into this frame, but there's actually, the minute it goes back behind the kind of shutter with the ABB on it, so that lifts up, the boiler's sucked in, and then there's all these robots that come down and literally start welding it completely into place. Full manual section is just assembly, so it goes onto an assembly line and out the door for installation. They're exporting all over the world, and Ireland's kind of quite like New Zealand that way. We're very proud of where we export to and what we do. South Africa, New Zealand, and the weirdest one always for me was the Falkland Islands. Why do I say that? Because over a container a month of boilers went to the Falkland Islands. And I never believed there was that many people or boilers there. I think they were diverted at times. So what did I do? I started as renewable, right? I went in there and said, okay, I'll start setting up a renewable sector for the whole company. So we brought in solar thermal, we looked at wood pellet and wood gasification, and I set up that whole sector for them. Within 6 months, I transitioned into technical and export manager for the company. That meant a good change in my life, a busy period. Sounds glorious. I was traveling the world. I was probably away from home at least 2 weeks of each month. So it was pretty different and a busy period. But again, massive set of skills. I already had a great foundation behind me, and from there I looked after R&D, all the technical teams, all the warranty for the company, and launched new products. So some, I guess, high moments for me was we launched a boiler into the United States of America. Everybody knows in America, and it's still so true, everything's big. They don't believe things can be small. You know, and I'll never forget one of the first boilers we installed over there. I went out and went onto site with the plumber and made sure everything was okay, and the homeowner came home and said, "What's that? What's your new boiler?" And he was very proud of himself. "Take it out." The homeowner said, "What do you mean take it out?" He said, "It's too small, that won't work." Because the thing he had inside there was just colossal, you know. So launching over there, it's a total different process. On production, we literally had to stop production of our other boilers when we were manufacturing for the United States, and had to pay somebody to come over from the UK to inspect the full, from the sheet metal, the full production process all the way through to completed assembly. And they do that for your first 2,500 boilers, which is a long time when you're trying to get set up. Another one was a full stainless steel boiler for the German and the Swiss market, very particular, but we got there. And also managed the export markets. Always good. Some other items that I worked through was Ireland launched a system called BER. The emphasis of BER was its building energy regulations. It meant that if you or I were going to buy a house or rent a house, we could easily see by the colour coding, ABCD, whether the house was efficient or not. So if you were going to buy a house and it was rated D, you know that it's not really efficient. If it's A, it's a well-built house. However, as the government got a hold of it, they cracked it more and more and more and made it tighter and tighter and tighter. Put this in perspective. I was blown away when I moved here and I discovered that the standard cavity was, the standard stud was 90 mil. In Ireland it's 385 mil is the minimum you can do. So what we had to do as an industry was literally get into the background of all this and crack the code to make sure that you could still put in a boiler, put in your stove that you wanted, actually get the customers what they wanted inside the house, because it basically meant you couldn't do anything. So I worked across that and launched it to various other suppliers and national bodies in the country. Second thing is we completed a national roadshow a few times, but the national roadshow really was about training the industries, training the plumbers. I saw as my dad was getting older, it's hard to stay across everything, people are busy. So across about a year and a half in particular, on the major one, I trained over 1,000 plumbers in Ireland on where regulations were going and how they could actually manage it and run their business. Last one was a national award for a product that I launched, which was called the solid fuel heat exchanger. It was a real simple, basic box that I didn't think would win anything, but it meant a simple, safe integration of a solid fuel, uncontrolled appliance into an efficient, pressurized system, basically. And then a week before I immigrated, I had to present to government and all the head architects and engineers in the country as to where I thought the building code should go. Everybody laughs at this photo because some people typically say, "Where are you?" Because I'm hidden in the corner, tiny, in amongst all the men. But it was a big moment and a nice achievement really before I actually left the country. So then I jumped on a plane and our container went on a boat and we arrived 3 months later and we a bit sooner than that and moved to Central Heating New Zealand. So what is Central Heating New Zealand? It really kind of comes down to whole home heating. And it started out as a residential company. So it was two brothers from Christchurch, Lyle and Lewis Smith, who had the same idea. Both of them had spent time in the UK, both of them married Irish women. And when they moved over here, obviously they were used to central heating over there and their wives had never experienced an unheated house. So they wanted heating. So they bought a gas boiler and bought a couple of radiators and put it on a container, got it over, installed it, and kind of sat down that night when the heating was on and went, "Flip, there could be something here. There actually could be something here." So they set up a company, incorporated it in 2002, and started to hire plumbers already in 2003. So business was developing. We've grown absolutely year on year to a team of 50 now, and we could do it more. We've got all the various departments that you have, the sales, marketing. We've an install division in Christchurch, so we install residentially in Christchurch about 130 to 140 houses a year. All the products we have, we import ourselves from Europe. So it's primarily Europe, and we've got one Japanese supplier. I guess that is key because when you look at the engineering department, they're designing what product that we're in direct contact with the manufacturer with. So we've got all the technical know-how, we've seen the factories, we know how everything operates. But the engineering is core to it. It's core to it because it's not normal here. It's not part of the plumbing trade. It's not part of your qualifications, you know? So we have a core engineering group that design residentially and commercially. How do we do it? Not telling you how to suck eggs, but we literally look at heat loss. So we basically look at how the fabric of the building loses heat, how quickly it loses heat, and take in ventilation and filtration into consideration. How do we overcome it? Simple maths, you guys know this. We look at outside temperature and the rate of heat loss of that room and how much heat we need to put into it. However, none of these calculations exist. And if you go back to the days of my dad plumbing, he'd get a set of plans and he'd measure it out and know exactly what radiator to put in because it's part of the trade. It's part of what you're brought up with. So we've, over the years, have had to come up with our own designs. I'll give you just a couple of snapshots as to how. This would be what we call a simple spec house, right? Not much to it. So what we look at, this is underfloor heating. It's the pipework that's located in the slab. So before they pour the slab, when the mesh is down, the installer will literally put pipework into the slab, tie it to the mesh, and they pour the concrete over it. It's as easy as that, as long as you don't punch the pipe. We've a thermostat that controls the temperature in the room. So that says, I've dropped below my desired temperature, please turn the heat source again. And then obviously we have to have a heat source. So in this instance, I've just shown a photograph of what to us is an AC unit, but we actually have air to water units. Same principle, exchanger inside in it that converts the energy to water. Various types of emissions from the room. Underfloor, as I mentioned, we've got a Vario comp system. It's 20 millimeters. That's an underfloor system. It comes like a composite unit on the existing floor. We're at RADs that you guys have around campus. Yeah, and you've got a few of ours too around the place. And then we enter more intriguing projects, and I've one coming up next, where we go buffer tanks, larger, a bit more exciting, a bit more meat and bones to it. To put it in perspective, I took a quick look as to residentially, how many houses we designed last year, and we had over 1,500 houses designed last year. so we get through a fair volume. You guys would all know Millbrook in Queenstown. Beautiful golf course, super duper homes. We design an awful lot inside Millbrook. Most of the people in Millbrook, they're summer houses, they're batches, but they're 450 plus metres squared. So this was one that we actually completed in Millbrook that consisted of geothermal, so we did vertical bores, underfloor heating, 20 litres, it was the highest spec that you could actually look at. How do we do it? I just said it's hard to get real technical in this, I said I'd give you just a bit of a snapshot. So we've come up with all our own IP in-house. So we've got all our own design calculators that we use. What we basically do on the heat loss principle that I spoke about is we literally enter in all the various rooms, all the external walls, it'll all make sense, how high the ceiling is, what the R values are, double glazed, single glazed, triple glazed, and that typically will give us an output then. Right? It'll tell us what the heat loss of the overall house is, and I'm looking in at underfloor here. For underfloor, our floor coverings are pretty critical, so we consider the floor coverings, carpets and insulator, polished concrete, beautiful. We look at the radiation required, so how much heat, how many watts per metre squared do I need to get into this room to actually heat it, and then we look and see can we actually meet the heat load or not. All right. I mean, even in the 7 years that I've been with the company, we've just come on leaps and bounds how quickly we can actually do it now. This is domestic, commercial is even more exciting. Then we do the pretty picture, as we call it. It's literally for the householder to understand what the hell they're getting. So we have to do the pretty picture in that instance. This is showing the vertical bore. So those holes there, the little circles that you guys can see, are where they came on site and actually drilled vertical bores. We put 2 pipes down inside in it, and the water literally flows through that and comes back into a geothermal heat pump. So a reasonable amount of design on that. Because the industry is so unknown, we actually have to assist the installer and the electrician all the way. So we have to show them the loop calculators. If they lay the loops wrong, we can't get water down it. We actually don't have enough flow rate down through the pipe. So we've got to make sure that everything's okay there. So we'll complete a series of underfloor loops, so at least they get it right. And then we get into the fun stuff where we actually do the wiring diagrams, the mechanical diagrams, final connections, so at least now the plumber's getting on board, but the sparky won't make a mistake. So we kind of cover the whole project that way. Briefly to run through some of the calculations we have and that we have to consider. Obviously the heat loss, we've got to make sure the pipes are sized. Have to ensure the pressure drop is right through it. Literally you guys can see the list there. Humidity is another big one that we consider now because we've just gotten into cooling relief, and I'll show you guys a bit more on that in a while. Hopefully this will work. Do you know, this is always the moment that these videos don't work. So in this house, it's a reasonable size house. We were just looking at heating. So we have a heat pump and heat it during winter. We saw a niche in the market with the heat pump, they can all do heating and cooling. So we said, why can't we do cooling? So we worked with an Italian supplier and they developed a controller specifically for us. Reason being is we also monitor the floor slab temperature. Reason why we monitor the floor slab temperature is because, like in Ireland, winter comes and there's 8 miles of clouds and it doesn't disappear. Whereas here, look at, what day was it, Monday? It was beautiful during the day and then the storm blew through. And all our houses have loads of glazing. So our houses heat up really, really well during the day, but the minute the sun drops, the temperature just plummets. So we have a floor probe where we're constantly keeping the slab temperature topped up, so that when it does plummet, we can quickly get the heat into the room. So with the cooling, we also have to monitor humidity. So there was a lot more to consider. So they were very good. They worked with us in Little New Zealand and developed this controller. So with cooling relief, it's different. You don't have the air blowing on you from HVAC, etc. You can have like 23, 24 degrees still inside the room, but your body's actually very comfortable. It's radiant cooling that you're actually feeling. And the other thing, a lot of our staff members become guinea pigs. And one of our head engineers, James, was blown away because he has cooling relief in his place. But what he actually said was the difference with it is I can open my sliders, have my barbecue, and and the house was remaining cool. It was like as if the breeze through the house was assisting and reducing the temperature even more. So it's a whole new concept that we're actually trying to even introduce to the psyche of the end user. You know, you don't have to keep turning on that fan and the cold air blowing on top of you. Your air temperature doesn't have to be 16 degrees for you to feel cooler. So the big thing for us is to monitor humidity. And as a result, what we've done is calculate out a whole new set of sheets. So each room that you see there, the average gives you the average cooling that we can meet. 75, we can meet 75% of your cooling needs. And it goes by the time of day. So we literally take into account the orientation of the windows and the time, obviously. A couple of people have said to us over the years, well, we can't do that with an energy model. We can, but it'll take about 8 hours to complete and cost the customer an awful lot. Whereas with this, it'll take us 10 minutes extra with what we're doing. But something to consider with respect to humidity, we're not too bad here up in Auckland, Northland, they'd be an awful lot worse, is how much humidity actually affects everything we try and cool. So you can see as the humidity increases beyond the 50% mark, it literally just plummets the place. And it's a big thing for us to work on because we've got a lot of houses up in Auckland, Northland, where we really have to control the humidity on it as well. All commercial, I mentioned commercial, where we are involved and we have been involved in an awful lot of commercial jobs over the last number of years. I said I'd just pick one that kind of stands out to all of us at the moment, which is Metro Sports. So you guys will know all the big boys that are involved in that. And it's really just to give you an insight to open your mind that there's an awful lot of other companies that are involved, a lot of other opportunities within it. So this gives you a bit of an image of it. But I want you guys to consider all the other people that have to be involved with Paul Fenwick, with the construction company. All the suppliers actually become key in assisting with the design of it. Alright, so as you move through this, you can see various people are involved in it. And we were one of the primary ones with respect to the slab. Reason being, we actually had to draw this. I didn't draw it. Kudos goes to James Campbell, who drew it, one of our engineers. This was 60,000 metres of pipework. And this is going into Metro Sports. So when you guys are in Metro Sports next year, hopefully when it opens, and your feet are on the floor and you can feel it warm, you can say you've seen the bloody drawing. It took hours to complete. But we're only a small little snippet within that huge project that's actually making it happen. So, I know Sid asked the question at the start, how many of you guys have jobs? It's kind of a scary moment when you go out there, look at it. And really the emphasis out of that is think wide. There's lots of opportunities with various companies out there. And all you guys need is a starting stepping stone to take the next step thereafter. Here we go. That's what I kind of wanted to say. I'll never forget somebody said to me, I remember 2 lectures. The very first lecture, Sari said, was KISS, keep it simple, stupid, and always remember that. And B, get your foundation right. I know it's a structural degree, it's kind of sad, but it is so true. And we've had an awful lot of engineers come through us, and I always say to them, don't take the lift, take the stairs. If you take the stairs in your career, you'll get a great foundation that will set you apart from most. And it'll lead you in the right path that you can, the world's your oyster, you can be very successful in it. So just make sure wherever you go, you will be dying to get on to the next step. Just do it right. Listen to your senior. Let them train you the right way. And you'll succeed from there. Next one, don't be afraid of crossings. Flip, confused.com. Don't be afraid. I always say use your gut. Okay, if you get an opportunity or if something's ringing in your bell that you want a bit of a shift in a direction, don't be afraid of it. Most engineers don't end up engineering, right? They'll do it for a few years and then they'll hit that crossroad and they'll divert. I diverted. But my engineering degree always stood to me. All right, so when you get out, get your foundation right and start discovering yourselves. Start discovering what extra skills you have. Mine is talking. but you'll get there. Don't be afraid of crossroads. It's always worth taking a jump. And the last one is think far, think wide, and absolutely think high. Because if you have a plan in place, you'll get there. Just make sure you keep thinking about where you want to be, what your goals are in your career. Because if you have your goal, you'll absolutely get there. And I think that's it.